Okay guys, now we're going to start our unit on analytic trig, and we're going to start on pages 6 through 8, which is talking about simplifying and verifying trig identities. Okay, for this we're going to use our unit circle, and we're also going to use this section of our formula chart right here. Okay, so you're going to look at the tangent cotangent identities, the reciprocal identities, and the Pythagorean identities. So those three sets of identities are what we're going to work with to begin our unit. As we progress, we'll use more of these formulas, but for now our focus is going to be on those three. Okay guys, so starting our unit on simplifying and verifying trig identities, we're opening up with this question that says, use the fact that secant u is -3/2 and tangent u is greater than 0 to find the other 6 trig functions. Okay, so this is actually something we've done before. You might remember when we would draw our coordinates and then draw a triangle on there to help us solve a problem. Well, in this case, they've told us that the secant of u is -3/2, and that means that the secant is r over x. So I can match these up and say that r is going to be 3 and x is going to be -2. Now the negative always goes with that x because we're not going to be able to ever have an r value that's negative. So if I start drawing this, we're going to say, hey, I know that x is negative, r is positive, and my tangent is also supposed to be a positive number, is greater than 0, right? So tangent is equal to x over y, and if this is positive, then both of these numbers actually need to be negative, right? This is negative. That way it cancels out the negative on that x. So I'm going to draw my triangle, and it's going to end up in quadrant 3, okay? And we will use Pythagorean theorem to help us solve this for the y value, okay? So if we set up our Pythagorean theorem, we can solve for y, right? We'll have -2 squared plus y squared is 3 squared, okay? And we'll solve this out. We should get 4 plus y squared equals 9, and y should equal 5, right? So y squared is 5, and then we get y equals square root 5. And since I'm in quadrant 3, I know this is negative, okay? Once I've gotten all of these, I can use those to come up with what the other trig ratios are that we don't know. So starting off with maybe sine of u. Well, sine is y over r. And so my y value is -√5, and my r value was 3. And so we can then plug those numbers in, right? Cosine of u is going to be x over r, and we get -2 over 3. Tangent is going to be y over x, or sorry, x over y. And we have 2 over √5. Both of those are negative. Now those negatives will cancel each other out, and we're going to have to make sure that we rationalize this. So we're going to multiply by √5 on top and bottom, and I'm going to get 2 square root 5 over 5 for my tangent. So 2 more left that we don't know. We've already gotten the secant, so that one's free, okay? And we're going to do cotangent of u, which is just y over x. And so instead, it's just like the tangent flipped over. So we've got square root 5 negative over -2, or just √5 over 2. And the last one that we don't know, the cosecant, is going to be r over y. So we've got 3 over negative square root 5. And again, we need to rationalize this. We always want our answers in the simplest forms. So we've got √5 on top and bottom. And we're going to get 3 square root 5 over 5. And it is negative all over. Okay, so these are my other 5 remaining trig ratios. And you can see that all we did was plug in those numbers to get that. Okay, this is mostly a throwback to what we've already done before. Okay, so let's look at problem 2. Now this is really starting something new. This is where we're going to use that formula chart, and all of this stuff is going to come together. Okay, so we see simplify the statement. It says sine x cosine squared x minus sine x. So I'm not really sure where to start, but they've given us a nice hint here, and it says make factoring your friend. So in order to factor, we need to figure out what's common between these, and then we will separate it out. So the thing that I see common here is the sine x's. So I'm going to divide that away. So each piece I'm going to take out a sine x. So now that sine x is separated, I've got this cosine squared still in the first term. And minus, I took that sine x out of here, and I'm just going to have a 1 left over. Okay, so at least I've managed to separate the sines and cosines. Let's go ahead and try to continue breaking this down. Now, the hint also asks us, hey, what does it mean to simplify? Well, I want to be able to get things to combine and maybe become smaller. And that would probably be a simplified version, okay? So we're going to use one of the formulas from our chart here. And there is one formula that uses cosine squared, all right? So there's a Pythagorean identity. And it says sine squared x plus cosine squared x equals 1. And my kind of alert for that, why did I know to use that, was because of this squared, okay? So when I see squares, Pythagorean identities kind of jump out at me because those are the ones that have squares in them, okay? So I see cosine squared x minus 1. Let's see if we can at least get something similar looking out of our identity here, okay? So what I'm going to do is I'm going to say, let's go ahead and get this cosine by itself for a second. Sine squared x, subtract sine squared x, and I've got cosine squared x equals 1 minus sine squared x. Now this might be enough for me just to plug this in here, but we can take it actually a step further and move this 1 back to the other side. And you're going to see it's going to match up perfectly with what I already know. So if I plug this in, I'm going to say cosine squared x minus 1 is equal to sine squared x. So I'll take this section and we're going to replace it with sine squared of x. And that is still being multiplied by this sine x on the outside. And now I'm like, wait, can I combine those two together? They're all sines. So finally, when I put this together, I'm going to have sine cubed of x. And this is my most simplified form, okay? My goal is to end up usually with just one term. One term is my goal. So sometimes you'll have something a little more complex than this, but usually when you simplify, you should try to end up with just one single term. All right, so this next question is asking us to simplify again, but this time our goal is to end up with everything only in terms of cotangent. So we actually want something that has no other trig function, so no sine, cosine, no tangent, nothing like that, okay? And our problem reads cosecant squared x minus cotangent minus 3, and that's kind of the expression we're trying to simplify. So our hint says, can we find a way to relate cosecant with cotangent? And if we look at our Pythagorean identities, we will find that 1 plus cotangent squared of theta equals cosecant squared theta. And what we can do with this now is that we're going to replace the cosecant in our problem right here, that cosecant squared, with 1 plus cotangent squared. So currently I'm going to replace this, and I'm going to have 1 plus cotangent squared x minus cotangent x minus 3. And now we can continue simplifying. Let's go ahead and combine our like terms. So I see this 1 and this minus 3. Let's make that into a minus 2. Get negative cotangent x and cotangent squared of x. Now, here we're already in terms of cotangents, but maybe we're trying to get away from cotangent squared as well. So let's just take a second and see if we can break this down any further. And what I'm going to do is actually pretend like all my cotangents are just x's for a moment, because this may look a little familiar to you now, right? This function, but just by saying like cotangent x is equal to x, right? we can substitute. And we can now see that it's actually in the same form as a quadratic. So we can break the quadratic down using factoring, right? The two numbers multiply to be -2, and they're going to add up to be -1. So we've got x minus 2 and x plus 1, which means finally I can turn everything back into cotangents, because remember we said x was actually just cotangent x. And I've got cotangent x minus 2 times cotangent x plus 1. And the reason that we're doing this is just so that we're aware, hey, we can actually break this down just like it was a quadratic. And that's it. We're just saying, hey, look, I've got my answer simplified now. It's broken down, and there's only cotangents in there. On number 4, we've got sine t plus cotangent t times cosine t. And we want to simplify that into one trig function. So I want my result to be a final answer that's only one term. Okay? So they gave us a hint, and they said maybe rewrite everything as cosine and sine. So we're going to need some way to connect sine and cosine into cotangent. And the formula we can use is cotangent x equals cosine x over sine x. And that's going to be the cotangent identity from your chart. Okay, so let's rewrite our problem. Sine t plus cotangent t times cosine of t. And again, what I'm going to do is I'm going to replace this cotangent right here, and I'm going to turn it into cosine over sine. And we'll just continue bringing the rest of the problem down. So this is still going to be times cosine t and sine t on this side. Okay, so now what we can do is we can continue combining stuff now that everything's in at least only two terms. Let's combine on the right-hand side. So I'm going to write this as being over 1. Cosine times cosine is going to end up being cosine squared of t over sine t plus sine t on the front. Okay, and now that I'm here, let's go ahead and get some common denominators so I can combine this all into a single fraction. So right now I'm going to go ahead and put this over 1, and we'll multiply each side by sine t. So sine t on top and sine t on bottom. So now that I've done that, I'll bring this up over here, and we've got sine squared of t over sine t plus cosine squared t over sine t. All right, so now at least this is ready to combine into a single fraction. And I've got sine squared plus cosine squared on top and just a plain old sine on the bottom. So we got sine squared t plus cosine squared t over a single sine t. All right, let's see what we can do with this now. Now, this top bit, I'm hoping, looks a little bit familiar. It looks like one of your identities that we already know. You should remember, hey, sine squared plus cosine squared is equal to 1. So this entire top piece that I've highlighted is actually just equal to 1, and we're 1 over sine t now. And now that I've got that, it becomes very simple to use just the reciprocal identity and turn this into cosecant t, okay? And if you forgot, that is also one of our identities. So this is a reciprocal identity. And you can find all of these on that chart, right, in that section that I mentioned at the beginning of the video. All right, so we use 3 identities here, okay? The first one was the tangent and cotangent identity. Then we used a Pythagorean identity, and then finally a reciprocal identity. The goal is to simplify by finding pieces of our formulas that will match up with this, and then we can plug them in and combine and cancel different terms. All right, so number 5 says, perform the addition and simplify. We've got sine theta over 1 plus cosine theta, and that is being added with cosine theta over sine theta. So in order to be able to add this, just like our hint says, we're going to need a common denominator. So let's start by writing this problem out, and then we'll just take each side and multiply it by the opposite side's denominator to get a common setup. So I'm going to take the right-hand side, and I'm going to multiply it by 1 plus cosine theta on top and on bottom. Can't just do it on one side. So now what we can do is distribute on this top part, okay? So I've got cosine times 1 is cosine theta, plus cosine times cosine is actually cosine squared of theta. Okay. And the bottom part, I'm going to leave without distributing, okay? So for now, let's just leave this alone. If we need to, we can combine it later, okay? But for now, let's leave it alone. Now, on the left-hand side, let's take the top and bottom, and we're going to multiply it by sine theta. So times sine theta times sine theta. So on top, sine times sine is going to give me very simply sine squared of theta over, and I'm going to, again, just leave this separate. I'm not going to mix them together yet, so no distribution involved, okay? And now I've got these two fractions, and they're ready to be added together because they've got the same denominator now. So I'm just going to rewrite this as a single large fraction, and let's see if we can simplify something. Sine squared theta, that's that first term, plus cosine theta plus cosine squared of theta. Okay, and on bottom I've got 1 plus cosine theta and times sine theta. Okay, awesome. All right, let's see if this actually does simplify into something. So the first thing I'm noticing, wait a minute, I see some squares, and those look kind of familiar to one of the identities that we've used before. So over here I've got sine squared and cosine squared. Those are going to be one of the identities. So take a second, see if you can find it on our chart. It'll be under your Pythagorean identities, right? So the Pythagorean identity we are talking about here is sine squared plus cosine squared equals 1, okay? So sine squared plus cosine squared equals 1. So I can take those two pieces and just rewrite this to be 1 for those two. So now I've got 1 plus that cosine squared theta that I haven't used over 1 plus cosine theta times sine theta. So now, do we see something else that we can simplify or break down further here? Sure, let's cancel out these two 1 plus cosines. And now I'm just left with 1 over sine theta. And this is actually one of my reciprocal identities. So remember, don't ever leave it as just 1 over something. Always just change it back into its reciprocal form. So this is going to become cosecant theta. And that is my final simplified answer. All right, guys. Now we have a problem that says rewrite 1 over 1 plus sine theta so that it is not in a fractional form. So this is actually a kind of challenging problem, and it requires us to jump through a few mathematical hoops. And the hint they've given us is to use the conjugate of the denominator. Now, you may not remember what that word means. Mostly we used it when we talked about complex numbers. So what the conjugate means is we're going to change that sign that's in the middle of the bottom. So I'm going to change that into a minus. Instead of plus, now it's minus. And I can't just multiply it on the bottom. I'm going to do it also at the top. And now that I've done this, I've set this up, let's see what we get. Remember, we have to distribute and FOIL things out. So currently on top, I've got 1 minus sine theta over the bottom is going to be 1 times 1, 1, 1 times minus sine theta, Then we've got plus sine theta. Okay, and the last one is going to be minus sine squared of theta. So wow, we've got quite a bit going on down there. Let's see if there's anything we can combine already. Well, I see this minus sine theta and plus sine theta there. Those can cancel out. And now I just have 1 minus sine theta over 1 minus sine squared of theta. And now I want to simplify this. So we need to get away from being a fraction. I notice, though, there is a squared down here. I wonder if we can use that Pythagorean identity that we've been using a lot. Let's use that sine squared plus cosine squared equals 1 and see if we can substitute something useful in here. Okay, so I've written out the identity here, and we can kind of see what's going to happen here already. Let me move this sine squared over, and it looks like I'm going to get exactly what I've got at the bottom there. So sine squared x, we'll move it over. We can just rearrange it into what we want. And I've got this cosine squared x equals 1 minus sine squared x. So now we've got this solved out, and we're going to substitute over here. Let's replace that with a cosine squared now. So top part, 1 minus sine theta over cosine squared theta. Okay, now that I've replaced the bottom, I still need to get it away from being a fraction. And to do this, we'll use another identity actually. Okay, so we're going to use a reciprocal identity. And there should be one that helps me get rid of cosine from the bottom of a fraction. So look for an identity that says that. Okay, I'm hoping that you found the identity that says secant theta equals 1 over cosine theta. Okay, so with that identity, what I'm saying is that if I move cosine to the opposite side of the fraction bar, because we can imagine this is like secant over 1, we can move it and change it into a secant, right? So let's move this to the top and make it a secant. So now I've got 1 minus sine theta times secant squared of theta. And that's going to be my final answer for this problem. 1 minus sine theta times secant squared theta. It's simplified. It doesn't have any more fractions in it, right? By moving that cosine squared to the top as a secant, we've now gotten rid of all of the fractions. Now, we do have to get the bottom to be only one piece, like cosine squared. We wouldn't be able to do this if it was still as 1 minus sine squared. Okay, so number 7 actually looks like a very messy problem. It says, rewrite natural log cosecant theta plus natural log of tangent theta as a single logarithm. Simplify the result. Well, we may have to look back at our Algebra 2 notes to see that, hey, this requires us to remember the log rules, right? Properties and rules of logarithms, which if we look back to, we'll find that adding logs actually makes them multiply. So for example, log A plus log of B is equal to log of A times B. Okay, which means that we can do the same thing here. We can rewrite our natural logs, natural log of cosecant theta plus the natural log of tangent theta. And we can rewrite that as those two multiplied together instead. So we've got a big natural log, cosecant theta times tangent theta. And I'm kind of looking at this and going, well, there's no common terms, and I don't really see any squares. So I'm going to move to my other strategy, and I'm going to try and change all of these into sines and cosines, okay? So I'm going to start with cosecant. Let's look at our reciprocal identities, and we'll find that cosecant equals 1 over sine theta. And tangent is equal to sine theta over cosine theta. And we can just bring the rest of the problem down, natural log. Pretty immediately it jumps out at us that, hey, wait, signs are going to cancel out. They're on opposite sides of the fraction. And now I've got this natural log of 1 over cosine theta. I wonder if I can break this down any further, actually. And what we can find is 1 over cosine, that's actually also one of my identities. So 1 over cosine is actually just going to be secant. So I've got natural log of secant theta. And that is my final simplified answer. Okay. What did we actually do here? We took cosecant and tangent and we made everything into sines and cosines. And what did that actually accomplish for us? By making everything into sines and cosines, we were able to find something that canceled out. And then we got an answer that could be simplified into something smaller using a reciprocal identity. And so this was simplifying and using that identity. And that's it, guys. We can use the identities by looking for places where they match up with our formulas. When I saw that 1 over cosine, I remembered, I was like, wait, that looks like one of my identities. Let me check and match it up with something.